Okay, let's start with these problems. These are just going to be some vocabulary questions because, first questions are vocabulary. Okay, write down the vocabulary term most closely associated with the following problems. The highest or lowest point of a quadratic. Does anyone know what this one is?
Vertex?
Yep, that's just the vertex. Okay. You just stroke. Okay, so yeah, this one is just vertex. Okay, next one. The line that divides two equal parts of a quadratic. Like that.
Axis of symmetry?
Yep, that is the axis of symmetry. Okay. A function that can be written in the form f of x divided by g of x, or f of x and g of x are polynomials.
Rational?
Yep, yeah, it's a rational. And let me move this here. Stage asked for it. Okay. This line is approached by a function as the function approaches infinity. It may be crossed by the function. So we have two possible scenarios. It's either the vertical or the horizontal. So if we have a vertical asymptote, it would look something like this. Let's say it's at x equals 2. Okay, this red line is things we cannot cross. Would it make sense for us to go into x divided by 2 if our function was something like x divided by x minus 2? No, because we would get division by 0. So in this case, we just simply cannot cross the vertical asymptote. So that means that the answer to this one is the horizontal asymptote. Because there are cases in which you can cross it, like this. All that matters is that you get closer and closer as you approach infinity. Yeah. And if you want an example, it could look something like this. You could do sine of x divided by x. This is also sometimes called the sinc function in engineering. And we see here, as you approach infinity, you get closer and closer. So the answer to that one is the horizontal asymptote. Okay, let's go on to the next one. One way to obtain this line is to set the denominator of a rational function equal to 0.
Vertical asymptote?
Yep, vertical asymptote, as we saw here. If we set the denominator here equal to 0, we get x minus 2 is equal to 0, x equals 2. Then that gives us this boundary that we cannot cross, because we don't want to divide by 0. And if we plugged in 2, we would get 2 minus 2. If I'm less than 0, then you know the parabola never touches the x-axis. Who am I? So this is talking about the types of solutions. If it never touches the x-axis, it means there are no solutions. What could that refer to?
Discriminant?
Yep, that's the discriminant. Discriminant. And the last term is when a quadratic has both of its solutions in one place. Okay, this one's called a double root. Double root. Apologies about my handwriting, I'm writing with my mouse this time. Okay. And if you want to see this in action, you just write the same root like this, x minus 2 times x minus 2. And it's only got one root at 2. Or if you want to see the general solution, x minus k squared. And it will always just have one solution. onto quadratic forms. Okay, the first one, by applying the zero product property with this form, you can solve the roots of the quadratic. Okay, in the zero product property, that's usually when we have terms like a times x minus 2 times x minus 4. And we set this equal to 0. The zero product property, it just tells us that if you set one of these equal to 0, then you've solved the quadratic. So that means x is equal to 2 and that x is equal to 4. And this form is called factor form, since we break it down to factors that we can use a zero product property on. Factor form. And an alternate name for this form is, since these are the intercepts as well, x equals 2, x equals 4 are the x-intercepts, this is also called intercept form. Okay, so this form has two names. When you write it as x minus, you can actually use whatever variable you want, x minus a times x minus b if you want. Okay, on to the next one. You can use this form to apply the quadratic formula. Okay, so we know the quadratic formula works if our form is like this. Ax squared plus bx plus c is equal to 0. Okay, and the name of this form is called general form. And using these coefficients, we can solve with the quadratic formula. Okay, 2.3 here. This quadratic form directly tells you, add an s here, left one out, tells you the minimum or maximum of a quadratic. So in other words, it's asking for the vertex of a quadratic. If we want the vertex of a quadratic, we can write it as y is equal to a times x minus h plus k. And this form, since this is the vertex, is called vertex form. Another form, yet a little contested, is that it's also called standard form. These are the two names that will be assigned to this form for the sake of this test. Okay, oops. And now let's delete this. 2.4 uses expressions to find axis symmetry. That will be negative b over 2a, which you can find in the quadratic formula. You continue this, square root of b squared minus 4ac. The axis of symmetry is hiding here in plain sight. Okay, on to the last one. This little expression can be represented by a triangle in the quadratic formula. That would refer to the discriminant. And one fun thing about the discriminant is that it's actually been featured in an episode of Peppa Pig, where Daddy Pig tries to show Peppa and George the quadratic formula. And here he defines the discriminant is this little triangle, which is equal to b squared minus 4ac. Okay, nature of quadratics. A ball is thrown with a parabolic trajectory. The ball's motion can be modeled by f of x is equal to 5x squared plus 8x plus 2. Write the function in vertex form and then find the vertex. Okay. Do you guys know what the general form of vertex form is? Oh, we know it's gonna be y something.
Wait, what was the question? Sorry.
Vertex form?
Oh, y equals a parentheses x minus h parentheses plus k. Oh wait, squared.
Yep, squared plus k. this is vertex form. H of k, or sorry, H and k are equal to the vertex.
Yeah.
And this A term here is always the same. So we can just plug in the A term here, and that reduces one variable. So you get y is equal to 5 times x minus h squared plus k. Okay. And if we want to find the vertex, do you guys know how to find this h term, which is the axis of symmetry?
Yeah. You do the b term divided by the a term.
Negative b over 2a.
Yep,
Yeah.
negative b over 2a. Okay, so negative b is negative 8 divided by 10. So that's, we're just going to write it in decimal form, negative 0.8. Okay, so we have the h term now. X variable. Okay, 5 times x plus 0.8. Since we do minus 0.8, and we square this, plus k. Now to find the k term, we're going to plug in negative 0.8 into the quadratic. So let me get a calculator real quick for that. And these websites are unusually slow today. Okay, so let's say f of x is equal to 5x squared. X 2. We're going to plug in f of negative 0.8. Okay, so negative 1.2. So 5 times x plus 0.8 squared minus 1.2. This is the vertex form. And along the way, we did find the vertex, so let's just write that down to satisfy the problem. So negative 0.8, comma, negative 1.2. And in this context, since we're talking about a ball being thrown, we're going to assume that the negative just means that it was below the ground. That's strange, but that's what the problem's telling us. Okay, next one. Find the solutions to the quadratic b of x minus omega times x minus pi. So let's look at the original factored form. Factored form is a times x minus, you could actually use any variable you want. So I could do x minus n times x minus l. And you can set that equal to 0. And if you want to find solutions, you just do x minus n is equal to 0. So n is one of our solutions. And for this one, you do x minus l is equal to 0. So that means x is equal to l. So just telling us is that we can actually just ignore the a term in this context. So let's see if I can erase this. Okay, it's gone now. The phi term does not matter. Or phi factor. Okay, and now we just do the zero product property on both of these. So x minus omega is equal to 0. So x is equal to omega, whatever it may be. We don't actually have to know what it is. Now for the next one, x minus pi is equal to 0. So x is equal to pi. Okay, write the quadratic with a double root at x equals 1 in vertex form. So do you guys know how to write quadratics given their solutions? We would use
In intercept form.
Yep, intercept form. Intercept form, or alternatively factored form. So we would write x minus 1 is one of our solutions. And x minus 1 is our other solution. So we could write this as x minus 1 squared. But there's one thing to keep in mind here. There's an a term here. We could make it whatever we want, and it would still have a double root at 1. So 2 times x minus 1 squared is equally valid as 4.67 x minus 1 squared. And since we're given this freedom, I would write this problem as just a times x minus 1 squared, and we account for every possibility. And if you want to see that, write this, and plug in a. You see here that no matter the value of a, you're always going to have a double root at 1. Close that. And that covers the nature of quadratics. Okay, time for the next section, which is applying discriminant. Okay. For which value of a will ax squared plus 2x plus 2 equals 0 intersect the x-axis only once? So, well, let's pretend this wasn't here. What would you use in this problem? You'd use a discriminant, which is what expression? Does someone know it?
B squared minus 4ac.
Yep, so b squared minus 4ac. And we can intersect the x-axis only once if this is equal to 0. Okay, so let's plug in our terms. So b squared is just going to be 4 because of 2 squared. So 4 minus 4 times a is just a, capital A, to be specific, times c, which is 2. This is equal to 0. So 4 minus 8a is equal to 0. Negative 8a is equal to negative 4. So that means that negative 2 a is equal to 1 if you divide both sides by 4. Okay, so a is equal to 1/2. You could have skipped these steps, but I wanted to do every single one. Okay, so that's the answer to that one. It's 1/2. Now on to the next one. This one, just by looking at it, you can see it's a little more challenging. Okay, for which values of h will f of x equals 3h x squared plus 2x times the quantity x minus 1 plus 2h never intersect the x-axis? Okay, so we're going to use the discriminant again. So b squared minus 4ac. And if we never intersect the x-axis, that means we have imaginary solutions, which can only happen if what?
Less than 0.
Yep, less than 0. Okay, let's plug in our terms, even if they're kind of ugly. So 2 times h minus 1, all of this squared, since this is our b term, minus 4 times a is 3h, times 3h, times c, which is 2h. And all this is less than 0. Okay, let's work on this first. So we're going to have 2h minus 2, and this quantity is squared. If you don't know how to do this right off the bat, you can use an area model like this. Here's what I'll do. 2h minus 2 times 2h minus 2, 4h squared minus 4h minus 4h plus 4. Okay, so this big chunk is adding all of these. 4h squared minus 8h plus 4. Okay, and now for this, it would be negative 4 times 3h, so this part is negative 12h, and we multiply by 2h, so that's going to be negative 24 h squared, okay, minus 24 h squared. Just making sure I didn't skip any terms. Okay. And this is less than 0. At this point, I would put it into a graphing calculator because you don't want to put 24 or 4 into the quadratic formula. Okay, so change into an x because the calculator understands that better. Minus 8x plus 4 minus 24x squared. And that is less than 0. If it didn't give you the shading, or if it was blocked on the graphing calculator, you could just set it equal to 0 and do the test point method that Ms. Frisbee showed. Okay, so in this case, x must be less than negative 0.6899 and x must be greater than, so not and, or x is greater than 0.2899. If you want exact solutions, you would just plug this into the quadratic formula, which is negative v plus or minus v squared of v squared minus 40c all over 2a. Okay, now that one done, let's go on to the last one, which are asymptotes. Okay. Sorry, I sound a bit tired. I didn't get that much sleep. Okay, now on for asymptotes. The horizontal asymptote and vertical asymptote of a function f of x is equal to x squared plus 4x plus 4 intersect at a single point, divided by x squared plus 2x plus 1. And the coordinates of this point can be expressed as a comma b. What is the value of a plus b? Okay, so it's saying the asymptotes of some function intersect at some point. So first, if we want to find the vertical asymptote, what would you do?
Set the denominator equal to 0.
Yep. So we would do x squared plus 2x plus 1 is equal to 0. You would use quadratic, factoring, grouping, rational root theorem, or whatever you want, and you would get x plus 1 squared is equal to 0. So x is equal to negative 1. Okay, and if we plug in negative 1, we would get 0 in the denominator. So that means our vertical asymptote is negative 1. The reason I'm putting it in the y-coordinate is because let's just imagine our function is something like this. And the horizontal asymptote acts like an x-coordinate, and the vertical asymptote would tell you the y-coordinate. Okay, so now that the vertical asymptote is y, we have to find x. Okay, and the definition of horizontal asymptote is the value we get when we keep adding and adding until we approach infinity. So let me duplicate this. idea is if we keep adding and adding until we get into infinity, then what happens is these little terms become irrelevant. And we're left with just 1. If you want the formal statement of this, you would divide the leading coefficients if they're equal degrees. So we get just 1. 1 comma negative 1, which when we find a plus b, that is just 0. Now for the next one. Let v of x equal to this rational function. To the nearest hundredth, what is the value of v of 80? Any guesses for this one? No guesses, okay. I guess it does look scary.
1/10 maybe, or not 1/10, 1/8.
1/8 is pretty close. We're gonna see what happens. Let's get a calculator out. Just write the summation. Okay, this is the function just stated in summation notation. And we're going to plug in increasingly large values of x. See what happens. F of x is equal to 1. We get just 1. Sorry, need not equal to 1. F of 1, we get 1/9. So we get 1 comma 1/9. How about we plug in 2 to this? We already get some scientific notation. 2 times 10 to the negative 22 power. Let's do f of 3. Even smaller. So let's do f of 80. This times some like unfathomably small number. So the idea of this problem is just, if we have this ginormous polynomial being divided, and the top is just like this insignificant thing, it's going to be just 0. Like if I told you this is in how much depth you are, you basically have 0 money. At this point, you have so much little stuff that doesn't matter. So the answer to this one is just 0. Okay. And that should conclude all 5 sections. Does anyone have any questions? Or anything you want to review? No questions. Okay. So let me stop screen sharing now. Okay, good question. He doesn't go over oblique asymptotes, right? No, the answer is no. There are no oblique asymptotes.
She said they wouldn't be covered, yeah.
If you did want to find them, you would use the synthetic division we learned in Heisler. Okay, I'll be ending the meeting now. Thank you guys for coming.